Sometimes in the course of solving mysteries in astronomy, ideas are advanced to explain a discrepancy that are considered for a time because they are plausible, but ultimately fall off the table when the problem is solved through other means. A good example of this is the now solved solar neutrino problem, which was a hotly debated mystery for decades until a solution presented itself. What happened is that in the mid-1960s, solar physicists noticed a somewhat large and pronounced discrepancy between the flux of solar neutrinos that should have been produced by the Sun through measurements of its luminosity versus what was actually measured, which was much lower. This was a vexing problem because the discrepancy was just so big. The resolution, in a nutshell, which came in 2002, ended the debate almost instantly. It turns out we simply misunderstood how neutrinos work. They were thought to be massless when they were not, and they can change states. Mystery solved, which probably would have been solved sooner, but there were holdouts in the scientific community that simply did not want to modify the standard model. In other words, a bias. But in those intervening years from the 60s to 2002, many different solutions to this problem were advanced. Most ended up wrong and fell off the table. But there was one solution left on the table after the mystery was solved that is now somewhat forgotten that was plausible and still is, that fell into obscurity for lack of a need to invoke it. But in some sense, it's making a comeback. Proposed in 1971 by Stephen Hawking to solve the solar neutrino problem, this idea involves one of the most enigmatic but unproven possibilities of the Big Bang. Hawking advanced that the neutrino problem might have been solvable if the Sun hosted a primordial black hole at its center, which would have been formed in the Big Bang itself. In other words, stars can absorb, or even form around, primordial black holes. Obviously, when the actual solution to the problem became evident that neutrinos had mass, there was no longer a need to invoke a primordial black hole in the Sun. Except we still have an outstanding mystery in the universe that such a thing may help explain. And it's an even greater mystery. It's the question of what makes up dark matter. Dark matter, of course, remains a highly contentious subject within science, in that we have no idea what it is. All we know is that something is exerting a gravitational influence far higher than the actual visible matter accounts for. You can invoke many things here, and many have, ranging from a non-interactive particle to matter hovering in another dimension to the idea that maybe our ideas about gravity on large scales are wrong. All are still fair game. But one option lies in the realm of black holes, especially primordial ones. Normally, you would be tempted to think that a black hole inside a star would very quickly eat the star. But primordial black holes, if they exist, don't have to be extremely massive. They can actually be the mass of an asteroid, and thus wouldn't have enough mass to grow any more than an asteroid does. Stellar mass black holes certainly would grow, and would eat the star if they were inside one. But the Sun is still here, so it must not contain one that massive. But that doesn't mean it can't contain one in principle. And it turns out there is a sweet spot, as far as mass, where a black hole, roughly the mass of the planet Mercury, would grow inside the Sun, but very, very slowly. Containing a black hole would eventually cause a star to behave very strangely. Accreting the star's fuel, the black hole would in turn cause intense radiation, which would push the outer layers of the star outward, which would then eventually cool the star until nuclear fusion simply stops, a star killer. The ongoing process of this should produce a star that's very chaotic, and there actually is a candidate type of star for this known as a red straggler. There are about 500 of these odd stars known, and they are part of a class of stars that defies the behavior of most normal stars. They are called stragglers because they sit outside of the normal parameters of stellar temperature classification, the Hertzsprung-Russell diagram. There are several ideas out there to explain these stars. The first involves what are known as blue stragglers. These stars are for some reason bluer and significantly more luminous than they should be. These hot stars tend to be seen in, or potentially in front of, dense star clusters, often seemingly near the centers of these clusters, suggesting that they are not foreground objects. One idea for these is that they are merged stars, where two stars collided in the dense star cluster environment, which resulted in them being somewhat out of place in the classing of stars. Because they underwent a collision process, most stars do not. They might also have simply been formerly binary companion stars that collided. Possibly related are the yellow and red stragglers, which might just be evolved blue stragglers. No one knows if they are all connected, but the red stragglers may also be something completely different, a star with a primordial black hole at its center. The idea of an exotic object embedded in the core of a star isn't new. There is a hypothesized situation where a red giant star could envelop a neutron star, termed a Thorne-Zeitkow object, and there are candidates for it. Basically, the situation would start with a binary star system. One member goes supernova and becomes a neutron star, and the other companion goes red giant, and the two merge through gravitation. It's actually an expected object in the universe, because we know of binary star systems where neutron stars and red giants orbit each other. And we also know that stars can merge, so it seems reasonable that these objects are out there, and their circumstances are such that they should produce chemical peculiarities in the red giant, which is in fact seen in several candidates. Primordial black holes differ here, however. We know black holes exist, and we know neutron stars exist, but primordial black holes created at the time of the Big Bang are still theoretical. They may exist, they may not, but there's no proof either way at this point. But entertaining the idea that they do exist, it should be detectable in the form of red stragglers that pulse in a very characteristic way. This is now being looked for. In a way though, if the red stragglers do represent this kind of hybrid star black hole, it would be unlikely that the Sun has this because it's not pulsing that way. But that doesn't actually rule it out. The size of a black hole is key here, and if it's just small enough not to produce the pulsating effect, then we might not have seen it. The weird thing here is that if the Sun does have a primordial black hole, it will change the Sun's evolutionary path over time. It would serve to cool the Sun and constrict the Sun's red giant phase, saving Earth from getting engulfed, but it would still get soundly baked in the future. Regardless if the Sun has a primordial black hole in its center or not, the idea that other stars may host them could be extremely important in astronomy. Confirming primordial black holes at all would represent a whole new regime of thought in the subject of dark matter, because it would open a way for gravity to be created through mass in a way we just really haven't been able to detect until modern times, without the need for invoking new particles or unknown physics. But there's a problem. Just how does a star capture a primordial black hole? One of the problems here is that primordial black holes probably would be moving too fast to be easily captured by a star. The dynamics of that doesn't seem like it would be very common, but it does not preclude the existence of primordial black holes in general. How these might have formed in the early universe is interesting, because it represents a mechanism that is no longer really applicable to the universe today, outside of a laboratory anyway. They would date from the inflationary era of the Big Bang, just after it, in a universe dominated by radiation and very high densities, so much so that dense areas of subatomic particles might have been so tightly compacted that they underwent gravitational collapse, forming primordial black holes without the needs of today, meaning a supernova with all its compression and circumstances. These primordial black holes would be older than the stars themselves, and it's even been hypothesized that the outer solar system indicators and inclinations of objects out there are best explained by the presence of an undiscovered planet. But it's also been advanced that perhaps the reason we haven't spotted it is because the gravitational source causing it isn't a planet, but in fact a primordial black hole in the outer solar system, which in turn would be very difficult, though not impossible, according to recent work on this, to detect. Another indicator of the existence of primordial black holes are findings by the James Webb Space Telescope of very early galaxies that are simply too early to be as large as they are, yet they exist. And again, the existence of a lot of these objects would go a long way in defining and explaining dark matter. But within this is another interesting aspect. If primordial black holes exist, and they are so numerous as to explain the effects of dark matter, then it might imply that there are many such objects fairly close, including the hypothesized one in the outer solar system. This would be the ultimate boon for science because it would mean that we have a bona fide black hole dating from the advent of the universe sitting in our lab, to be used as a laboratory to test physics in ways that we simply can't do right now, even with our particle accelerators. A new age of scientific inquiry would result, one that only a few years ago no one would have thought possible. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently musing about what belongs to what. Is it the solar system's black hole, or is it the much older black hole's solar system? Very vexing, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.